right, I think I'm live. Hey guys, thank you for joining this live stream. I actually wanted to do this live stream to share with you how to implement some simple filters that you may want to add into your game engine as you are building it. Now, the filter that I'm going to show you how to implement today is called the edge detection or the sobel filter. If I'm not mistaken, that's the name of it, sobel. Yeah. So it is a very simple filter actually. Let me show you how the differences. All right. So I'm going to remove the filter, and that's how your object will look like. Now, if I just show you the filter, the whole edge detection, that is how it looks. Now you can combine both your actual your original image and the filter, and it will look something like that. So I think that is something cool that you may want to implement. It's a very simple filter. I'm going to show you how to implement it, and you may also want to add that into a game object. Who knows? All right, so let me give you a brief how can I say that? Let me talk about the theory behind the whole filtering things, okay? So let me bring this up. Let me see, hopefully you can see that. So basically how you apply a filter in shaders is basically this is the representation of a filter that I just made up. It can be anywhere, like anything. And what you do is that you sample a particular texture, right? You pick a particular UV coordinate that you want to sample, and you pass that image, UV coordinate through the filter. And what you do in this case is basically you get the neighboring texels of that texture, and you pass each of those elements through the filter. So for example, I'm going to pass this particular UV coordinate or texture, right? So what I do first is that I will pick up this neighboring texel 23, and then multiply that times 3, which is the component of the filter. Then I would go to the next one, which is 27, and multiply that times the component of the filter, which is 2. Then 11, 1, then 76 times 2, 34, 3, and then on and on and on, and you add all of them up, and then you may have to divide that. And in this case, I'm dividing it by 9, and that gives me a new value, which is 63. So now the value of that particular texel in your texture is now 63. So that's how you apply a filter to an image, right? So now the sobel filter, which is, come on, it's taking a while to load here. Hold on, I'm having issues with the, okay, that's better. So the sobel filter here actually has two different components that you need to take into account: the horizontal filter and the vertical, right? And again, what you do, hold on, I don't know why I'm getting this. Oh, there you go. That fixed it. All right, cool. So as I was saying, you have the horizontal and the vertical. So let's say you want to sample this image right here, right? This whole image, and you pick this particular UV coordinate, right? So the first thing that you do is you pass this whole texture, this whole UV coordinate through this particular filter, right? So in this case, 23 times 1, 76 times 2, 5 times 1, on and on and on. So you are just adding the values, right? 23 times 1, then 27 plus, 23 times 1 plus 27 times 0, then plus 11 times -1, and on and on and on. And you do the same thing with the Y filter. And once you have all of these two values, what you need to do, since you have a value on the horizontal vector and then one on the vertical, you want to find the magnitude, right? So what you do is you simply do you do the Pythagoras theorem on both filters, right? And that will give you the final Sobel filter for that particular image. And that's basically it. It's as simple as that. So then the steps to apply a Sobel filter are the following, right? You need to sample the texture, right? Obviously. Then you need to compute the intensity for that particular texture, and then you apply the XX and SY Sobel filters, and then you get the magnitude of that. All right. So it's as simple as that. Now there are some things that you do need to keep in mind. Is that you should apply a blur filter to the image before you pass it through the Sobel filter. Not like a big blur or a Gaussian filter, just a small one, a very small filter, so that the filter doesn't get confused with some edges that you may not want at all. So it's as simple as that. So let me go back here and let me get out from here, so I can actually show you how to build one. All right, so if I go here, let me go new, don't save. All right, just give me 1 second, let me fix all this. In case you're wondering, I'm using this application called Code Live. It's really cool. And let me pick an image, all right? And a good image that I want to use for this example is this image that I have, which is the Doom logo. All right. Okay, so let me see how I can do this. Let me see if this will work well. Let me do it under a stack. Okay. Just let me make that 0. All right, so nothing will be shown. Now you may be wondering, what shader language is this? Hey Harlex, how are you? How's it going? I'm just talking today about how to apply an edge detection filter. So I'm about actually to show an example of how to apply it. So you may be wondering, what shader language is this? Well, this is the Metal shading language, and it's very similar to the OpenGL shading language. Okay, basically, I believe that when on the GLSL language Vec2, that's how you would use it, right? Well, that is basically equivalent. To doing something like this on Metal Float 2. So you have a Vec4, same thing. On Metal would be Float 4. All right. Same thing with matrices. All right. So even though I'm doing this using Metal, you should be able to port that to OpenGL shading language. It's super simple, like nothing big here. All right. So the first thing that I'm going to do is actually let me get this here. All right, so I have this image right here that we want to sample, right? Which is Doom, and I'm going to just create init color, and I'm going to sample it, right? So to do that, I will do texture 0, sample, and texture 0 sampler, and then I will provide my in v text code. RGB. All right. And what I will do later on is just to basically, you know, I don't like this call here, so I'm going to change that to final color. And I can say something like this: final color equals float for init color, and then just give it like that. So this should render the image on here, but it's not showing up. I wonder why. Let me see, what did I do wrong? So we have the image now, right? So now let's apply the filter, right? So we're going to create the filter, and the filter basically is going to require these parameters: the step of X and the step of Y, and those values will basically provide how much to move from the particular texture that you want to sample over, right? So in this case, we want to sample the one to the left, the one to the top. So we want to provide that particular step, so the shader knows how much to move, either right or left or up and down. Then we are going to provide the center texel, which obviously is the texel that we are working on right now, which is 34. From then on, we provide the texture, the image, and then the sampler. All right, and from that we go on. So let's work on this filter right now. All right, and just for reference, here's that's the filters for the sobel. All right, so the first thing that we need to do is we need to sample the texture and compute the intensity. And to do that, what we're going to do, we're going to go and visit every neighbor of the texel and compute the intensity, and also compute the corresponding filter values that we need to compute. All right, so we're going to start out with going to sampling. We're going to sample the one on the left, which is this one, and we're going to compute the intensity first, and then multiply, in this case, times 2. Right, so let's call it like this: float t left equals intensity, and that intensity will basically will compute green blade, probably be like half an hour, no longer than that. All right, so to compute the intensity, you can either just compute the magnitude of the particular color of the texel, or you can go and actually do the proper way, which takes into account the fact that our eyes are more sensitive to green and less sensitive to blue and all of that. However, I'm just going to go the easy route right now. I'm going to take the square root of each of the components of the particular color. All right. So I'm going to do color dot x times color dot x plus color dot y times color dot y, and then color dot z times color dot z. And that will give me the intensity that I'm looking for. So I'm going to return that. All right. So once I have that intensity, so now I'm going to actually get the texture. All right, so it will be texture 0, which is what I'm going to sample, and then I provide the sampler. Then my next thing that I need to provide here is I need to also so I'm about to sample the whole image. I need to provide the center image that I'm about to sample. In this case would be center, and then the offset, right? And for now, since I'm doing the T left, I'm going to say, okay, you know what? I want you to move negative X steps to the left. I'm sorry, we're sampling the top one, this one first. So it's going to be negatives to the left and 1 up. All right. So that would be negative stx, sorry, plus float 2 negative s step x, and then 1 up, and that should do it, right? So once we have that, we go to the next one, and the next one is actually the one on the left, right? So we do the same thing, right? Float left, and we get the intensity, we get the texture that we are going to sample, sample texture 0 sampler, then center, and in this case, what I'm going to do now is I'm just going to provide the one to the left, the offset, which represents the one on the left, and 0, and that should do it, right? And then the next one, I'm going to do the one on the bottom left, this one, right? And right now, what I'm doing, I'm just sampling the image. I'm sampling the image and computing the intensity. I'm not yet applying the filters, all right? So then I'm going to do the one on the bottom, be left, and it's going to be intensity texture 0 dot sample, center plus float 2, and this is going to should be negative step x, and then negative step y. Right, so we're done with that one. Now let's do the one on the top, and just to save time, I'm going to copy this because they all repeat basically. Okay, and this one, the one on top, is going to be only the step on the y direction, so this should be 0 and y, and that's basically it. Then let's do the one on the bottom. And this one should be negative step y. All right, so we have to go to and do basically 3 more, and those are the ones corresponding on this side. Let's see on the right. All right, so let's call them float t right intensity, but in this case, since we're doing the one on the top right, which is 11, is one to the one direction in the x, one step in the x direction and one in the y direction. So that's what we're gonna do. Step x. I don't need this. Boom. All right, and then the next one, we're almost done. So float right. Let me copy this again. And in this case, I don't need the y. And finally, the float bottom right. And in this case, what I need is make that negative. All right, so we're done with this. We have sampled the image, we have applied the intensity. Now let's apply the filters. All right, so just like I told you, this particular text here is going to be multiplied times 1, right? This one, 27 times 0, then 11 will be multiplied times negative 1. All right, so the way how we do that is basically float x, so t left, which is this one, needs to be multiplied times 2, right? No, I'm sorry, t left, I'm sorry, top left, which is 23, is multiplied times 1, right? So that, let's just multiply it times 1. It's not going to change anything, right? Now, the second one that we need to multiply is the left one, and the left one is multiplied times 2. So left times 2 plus the next one that we need to multiply is b left. B left is this one, bottom left, and that one is multiplied times 1. So b left times 1. but just so you have an idea why I have an idea, I'm gonna add it ×1. So that is that one. Now we also need to do the other one. Tab right, this one is multiply times -1. All right. And then the one on the right, which is this one, is multiply times -2, right? So what we can do, you know what, let's just do this. -t right, -2.0 times right. And then finally the last one is the bottom right, which is a, which is multiply times -1. So that one is going to be b right. All right. And then we need to do now the other one, which is y, which now all of the components are going to be multiplied by this filter right here. All right. So the first thing that we need to do, tab left, is multiply times tab left is multiply times 1. I'm sorry, did I mess this up? I don't know. I'm sorry. Okay, this filter is wrong. Oh my gosh, this is the exact same thing. I'm so sorry. So the Y filter is wrong. It's the same copy. I forgot to change it. All right, but don't worry. We're going to use this particular values, which is what I provided here. All right. So in this case, the one on the top left is going to be multiplied times -1. All right, so let me bring this up here. So will be t left times -1, then plus the next one, the one on the top, is multiplied times, will be multiplied times -2. So let's just do that. Top. And then if we keep on going, the one on the top right is going to be multiplied times -1. That's that. Then the one on the bottom left is going to be multiplied times 1 plus b left. Then the one on the bottom is going to be multiplied times 2 bottom. And then the one on the bottom right will be multiplied times 1 plus b right. All right. All right. So just so you know, if you are watching the replay, this particular filter is wrong. I forgot to change the values. All right. So, but no worries. What you can do is simply just reference the values here. This is the correct one. All right, so now once we have the x and the y, guess what we're going to do? We're going to compute the magnitude for both directions. So float color, and this one we're just going to do square root of x times x plus y times y. And then we are going to return that that particular color right there. All right, so now that's the whole filter. That's the whole sobel filter, right? Just so summarize, you compute the intensity using basically the magnitude of each component of the color. You obviously have to sample the neighboring texels, and you need to once you have sampled the neighboring texels, then you can apply the filters by following these values right here. And that's all what you basically do to it. And after that, you're all done, right? So now what is next? So now let's call that filter float 3, and let's call it edge color, all right? And in this case, what I need to pass is the following. Let me check something here. All right, so for here, I'm just gonna call this sobel, and then I need to provide the steps, right? The steps that I want to step either to the right or to the or up. So to do that, I actually provided this value right here, constant pixel step, it's set to 3 pixel step, and then I want to divide that by the resolution, and then I'm going to do that for the also for the resolution for the Y. And once I have provided that, I need to provide a center image, which is going to be the particular text, so that so it's going to be this one, in that v text coordinate, right? That's the coordinate I'm passing. Then I need to pass the texture that I'm going to sample, which is 0, and then the sampler. So it's going to be texture 0 sampler, right? And let me see, what did I forget? Okay, I need to pass use what pixel steps. Yeah, I meant pixel step. And step here also. All right. So now check this out. Check what's going to happen to the Doom image. All right. I'm gonna change the what I'm sending, and it shows up as only that. Now, what did I forget here? I want to change the color of it. Now give me 1 second. Why am I not getting the color that I want? Did I forget something? T left. I'm just making sure I have this correct. Left 2 plus B left minus T right minus 2 right minus B right. Oh, this is negative. Well, you have it as negative already, so let me change that. Minus 2 T right plus B left. Okay, and then I do the square root, and I get okay, this is the problem. I'm sending it Y, right? So I'm gonna change it to blue, and that's it. So now you know, I'm highlighting the edges with the color blue, right? You can also do the same thing if you wanted to make this, I don't know, like red, you know. Boom, you can do that. But in this case, I want to make it blue. All right, and that is it, right? So now that's how it looks, and that's basically all, right? So now what you want to do now is basically you may want to combine both textures, not the texture and the filter, float 3, and I'm gonna make this one a final color, and then you want to do a mix, right, between the edge color and the init color. And in this case, I'm going to make it by half. So now my final color is going to be this. Boom. That's what you see right there. Let me bring this up to 0 so you can see here. And I think if I do this will look better. So let me bring this up here. We're done. All right. So I'm gonna bring this up, and you see that the filter was able to basically detect the changes in color, right? Going from white to black in this case will provide this edge, and that's how you would do this. All right. So now, let's go and change this image, and I'm gonna go and change this image to the Doom Eternal logo, and that is that. You see how he also is able to detect that particular the edges of this. All right. So now I want to show you something. Let me see if I can do this. Doom Original, this one. All right. Something that you need to keep in mind when you are about to add this type of images. Let me open up GIMP right here. And I'm going to basically open up this particular image that I have, and because I want to show you something. So this is GIMP, and this is the image. All right. Now, something that you need to keep in mind when you are doing something like this is that you may have to invert this image before you send it over. Just like what here, I basically send it without any modifications, right? So what you need to do in GIMP is you have to basically invert the whole layer, right? And now remember that I told you that if before you apply the edge detection filter, you have to add a blur filter or a Gaussian filter. You have to do that, right? And it doesn't have to be a huge filter, value, not like that. It has to be something, just make sure that it's small enough. And the reason is that the edge detection filter requires you to pass the image through a Gaussian filter first before the edge detection filter can work on it. So keep that in mind, right? So here I'm just going to, I'm going to export this. And I'm going to call this Doom Eternal Regional 3. And I'm going to export this. All right, I'm going to hide this because I don't need it now. So now if I come over here, you see how the image will be fixed. See? And that's how it's going to look. All right, so that's cool and all, but now what if you want to apply this to an actual object in your game, right? And that's what that's the cool part, in my opinion, right? So let me bring up Blender, and I'm going to show you that I'm going to actually apply here. So let me bring up the pistol. All right, so this is the image that I want, that I'm going to, the model that I'm going to actually export onto Code Live, and also the texture that I'm going to use, right? So, but the texture here is blue, so let me just change that. Let me see if I can do that really quick. But let me do the red pistol color, right? So this is the image that I'm going to change. This is the texture that I'm going to apply the edge detection filter, right? So the cool thing about this app is that you can just export it. All what you need to do is go to File, Export, and then do a wavefront object file. And what you need to make sure is that, let me hope you guys can see this. All you need to do is to make sure that you have the right normals that include UVs and the right materials all selected, and then you can export it. I'm not going to do it because it's already exported. Once you have that, you'll be all good, right? So let me actually export that. So here, instead of me using quadrilateral as my primitive, I'm going to go to File, and I'm going to select my image, which is the pistol object, right? Which is what I exported. And obviously it's not going to look good because the texture that I'm applying to it is the texture from the Doom Eternal, right? So if you go over here, I'm going to go and change that image to the image that I need to use, which is the red pistol PNG, right? And now you have it there. So now that's basically now you have basically your 3D object with edge detection filters applied, right? You can basically change this from 0, which is going to show you just the value of the basically just the filter, right, the edge detection, or you can show your full image, which is going to be the full texture, original texture. If I change the value here, and obviously you may want to just have something in between so that you can see that, right? And again, you can do a lot of things with this object. I can make it rotate, and this is cool because now just by basically adding this simple function, the sobel edge detection filter, which is again very simple, you can add that to your game engine, and whenever someone is making a game, or even you when you are doing a demo, you can just call that function in your shader and basically have this type of edge detection applied. So this is very cool. So again, if you are watching the replay, I totally forgot to change these values. However, the correct values are found here. All right, so you can just check them out here. And if you have any questions, do let me know so I can send this to you. Now, the cool thing is that even though this was made using Metal, you can literally port this to OpenGL. You shouldn't have any problems whatsoever doing this. So I guess that is it, guys. If you don't have any questions, thank you for watching. And I'm sorry for the beginning. I had some technical issues. I don't know what was happening with the texture. It wasn't showing up, and it's a little bit weird. But again, you know what I'm going to do? I'm going to basically share this code on my Discord server, so that way you